Hey guys, I'm Miuccamatics and welcome back to my YouTube channel Miuccamatics. Today I'll be doing the proof of y, the logarithm or log of the number 1 to the base a, that is any base, is equal to 0, where the base is a positive number. Now we know log to the base a of x equal to y if and only if a raised to y equal to x. Now this is the definition of logs. If we want to find the log of a number to the base a, we need to find a raised to what number, that is the log, a raised to what number gives you x. So that's the definition of log. Now if you notice, we can take a raised to on both the sides. So we will get a raised to log to the base a of x equal to a raised to y. So if you notice, a basically the base and the log, they are inverse functions, hence they cancel out and gives you back x. So a and log are inverse functions. Now there are multiple ways to prove this. This is the most basic idea. So now we know a raised to 0 equal to 1, any number raised to 0 equal to 1. So since we know this, if we want to find log to the base a of 1, so a raised to what number gives you 1? So we know a raised to 0 gives you 1, so hence the answer is 0. Basically taking y equal to 0 and x equal to 1 in this case. So this is based on the definition. Now the next proof is, let us assume y equal to log to the base a of 1. Now we can take a raised to on both the sides. So a raised to y equal to a raised to log to the base a of 1. Now as I told you, a and log, basically the base and its log, the inverse functions, hence they cancel out. So a raised to y equal to just 1. Now we can express 1 as a raised to 0 because we know a raised to 0 equal to 1. Now we can, in order to eliminate a, we can directly assume y equal to 0, but a more formal way of showing this is basically we need to eliminate a. So since we know a and log are inverse functions, we apply log on both the sides. So log to the base a of a raised to y equal to log to the base a of a raised to 0. Now this is the property of logs. So if we have log of a raised to y, it becomes y times log of a. So now that's what we have done. So we take the power and multiply it to the log. So y times log to the base a of a equal to 0 times log to the base a of a. Now we know log to the base a of a equal to 1. That is because a raised to what number gives you back a? So that's basically 1. So so these two terms become 1. So we basically get y times 1 equal to 0 times 1. Hence we get y equal to 0. And since we took y as log to the base a of 1, we get log to the base a of 1 equal to 0. Now another proof. Log to the base a of 1, we can express it as log to the base a of a raised to 0. So it will be 0 times log to the base a of a. And since we know this is 1, it is 0 times 1, which will be 0. Basically a shortened form of the above proof. And this is the last proof, log to the base a of 1. Now we know 1 can be expressed as n upon n, any number upon itself. So log to the base a of a, n upon n. Now this is another property of logs. Log to the base a of x upon y is log to the base a of x minus log to the base a of y. So we just take the difference. So log of the ratio is the difference of the logs. So log to the base a of n upon n will give you log to the base a of n minus log to the base a of n. Now any number, if added to its additive inverse, so basically here in this case it's just difference, they'll just cancel out to give you the identity 0.